So I will edit it. Yeah, you can see the same thing here, but I don't like this one. This should be one by one. Yeah, one by one. One by one. Okay, multiplication of 2 there. So instead of this using this one, I will first try the logic threshold. Oops. Yeah, I will copy all those things. This transconductor, I will erase it for simplicity. And then let's just see. Okay. Yeah. Okay, so I will call my inverter sub-circuit expansion. No, here. Okay. X1 in out inverter dot DC V in 0.1 millivolt or just 1 millivolt. Dot print DC V out V in current, supply current. Okay. I think this is the one. Okay. This is the wrong one. Somehow it doesn't work. Do I have a problem? 2 few parameter sub-circuit inverter. Oh, that's a problem. So I have a problem in inverter call. Oh yeah, I missed the DD here. Do I have a problem? No, no problem. So, oh yeah. Works fine. Yeah, what is my logic threshold? Let me see. My logic threshold, let's put my current there. So where is my logic threshold voltage? Here. Yeah, my logic threshold is 1.267 volt, right? So where is my current? I will delete out all those voltage terms. Yeah, what's my current in that point? Current is around 58 microamp, okay? 58 microamp, 1.227 volt or something like that. That's a inverter, just an inverter. Maybe we can increase this inverter 10 times. This multiplication factor is 5 times larger. So this is a parallel connection, right? Let's look at my inverter. Simulate. Graph. Yeah, this one. In, out, current. Okay. Where's my logic threshold voltage? Logic threshold voltage is 1.26 or something. 27? Yeah, around the same. 1.29, 28, 29. How about my current? Current changes. Well, current changes a lot, right? Current changes to. How come this is too large? 300 microamp. Oh, is it right? Yeah, 55. Yeah, current change to 300 microamp, okay? But logic threshold doesn't change. Okay, let's try to use that constant current thing. So I will this VCM generator, I will put this constant current, and then I will put this small transistor for VBB, put large inverter, small inverter, and then I will, this DD I need it. This one, I don't need one. This sub-circuit, I will delete it. And then, let's see, I will change this reference current. reference current. This is let's see. What's the multiplication factor of this one is what? 1 by 1. So when it's connected to this inverter, this is a 10 by 1, right? 10 times larger. So this is because this M is 10. So 10 times larger current will. So if I sweep this current from 0 to 50 microamp, so it will sweep that current in the inverter 0 to 500 microamp, right? Okay, let's try to simulate this one. Looks like I have some problem. Nope. Oh, maybe not. Yeah. Inverter 1. So. Oh yeah. Okay. So let's see. My VB is fixed. My VB is not fixed. See, I am sweeping current, so my VB is increasing. X-axis is current. How about my VM? Oh, my VM, it tracks only a certain interval, right? My VCM is crazy. So this is my VCM, wow, 200, but that doesn't make any sense at all. So I will delete, yeah, in this region, it makes sense. I will delete out my VCM. So here you can see my VB yellow one is determined by that IREP. I sweep IREP from 0 to 50, 0 to actually 500 microamp for the inverter. And then, yeah, my VB should increase. And then my VM, yeah, it tracks for a certain period. In this interval, it couldn't match. It couldn't match. But from here to here, but here it drops. I think the current here is around 300 microamp, right? The logic threshold, the current at the logic threshold. If it goes up, then it doesn't work. So up until to the logic threshold current, so it matches, right? It matches. So if I put around 330 microamp, it should work fine, okay? Okay, question? Nope. Okay, let's try to AC analysis for this one. Let's see, how can we do AC analysis? Let's see. Yeah, 30 microamp looks fine, right? 30 microamp. So I will change this current into 30 microamp for DC OP. Do I have OP? Yeah, here. So I don't do, yeah, okay. I copy it. I open my AC, another file in a similar AC coupling must be there. Oh, this one. 2. Oh yeah, I think this is my AC coupling thing. The same thing with the AC coupling. Do I have AC coupling here? Oh, I must have AC coupling. Well, how come there is no C coupling? Oh, let's see. EMP, VDD, X3, inverter. Oh yeah, this is another DC coupling. Okay. Yeah, okay. Let's see. Yeah, this one is, let's simulate first and then look at it. Two, right? Yeah, this 2. So here, let's see. Yeah, for this case, I applied that VCM to another inverter. Okay. How come I don't have one? Oh. Yeah, here is the, yeah, I have the VCM generator. My VCM is generated by some, this OTA, right? See, I have something like that, I have something like that, and then see, I have a IREP there, and then I have a small MOS transistor is connected to there, and then this thing is connected to here, there, and then, so this is my VCM. So I applied this VCM to another inverter. Say this is my inverter, and then this thing is there. This is my VCM. So I just put a DC transfer curve of this inverter, right? So I just looked at it. So its logic threshold is around 2.7 or something, right? The current is around, I'm not sure exactly, 300 microamp or something like that. At the logic threshold. But this VCM will change that operating point, right? It depends on this IREP, right? This IREP is now 30 microamp, I remember, okay? So then, let's look at the simulation result again. So here's what's my logic threshold voltage here. Well, this is a much smaller, 1.3 volt, right? 1.3 volt. Let's see. So if I change the reference current into 20 microamp, what happens? 10 microamp may not work. Okay, I will simulate again with a 20 microamp. Then let's see, 2, and then my out, my VB, my in. Okay, what's my logic threshold at the 10 microamp? Oh, this is around the same. How come it doesn't change? Do I have a problem? In the previous case, 1.26, how come it doesn't change? 1.3, 1.31. Yeah, it changes only a little bit, right? How about the VB? Yeah, VB should change. That's a little bit weird. Let's look at my netlist again. Do I have a problem? How come this doesn't change? 30. I thought I put 20. Oh. Okay, now what? Simulate. I have to look at the 2, right? 2, and then out, in, VB. Did it change or not? Yeah, out. Yeah, it changed, right? My logic threshold is reduced slightly, 1.19, something like that, from 1.3. Okay. So this is this current is smaller than the logic threshold current, because some part of current is bypassed by that small inverter on the right hand side. Okay. So it works at the smaller current. Question? No? All right.